Hello everyone, welcome back to my channel. Today we'll be solving another Leetcode problem. So the problem is maximum twin sum of a linked list. This problem came in the recent contest of Leetcode, which was sponsored by Amazon. So the problem says that we're given a linked list of size n, and they are given the conditions for the twins of the linked list, that is the ith node and the n minus 1 minus ith node. So the ith node and the n minus 1 minus ith node are the twins of the linked list. Okay, so we have to find the maximum twin sum of the linked list, and the linked list is even. The size of the linked list is even. So this is a linked list. So the twins are 0 and 3, their sum is 7, and 1 and 2 are also the twins, so their sum is 4. So 7 and 4, the maximum is 7, hence the output is 7. Let's see in detail. So think of a way, how can we get the twins of a linked list? In linked list we can traverse only in this direction. Okay, can traverse only in this direction. We have no other direction to go. We are given the head and we can only traverse in the forward direction. How? By traversing in the forward direction we can get the twins. This is a twin, this is a twin, this is a twin, this is a twin. So one thing should strike our mind, that how about we divide the linked list into two? Then one from here and one from here, 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 and one from here. So we are at this position, and if by chance in anyhow we can get to this position while we are at this position, and we can get to the simultaneous position of this, then we can add it. So how can we traverse to the middle of the linked list? How can we traverse to the middle of the linked list? So these are the positions. This is the 0th, first index, second, third, fourth, fifth, sixth, and seventh, and so on. So we have to find the middle of the linked list, and not only the middle, the second middle, because we'll only be given even sized linked list, right? So we know an even sized array has two middles, so you have to find the second middle. Here the first middle is 7, the second middle is 1, so you have to find this 1. And we know in linked list we can find the second middle by tortoise and hare algorithm. What's that algorithm? That we keep a slope pointer pointing to the head of the linked list, and also a fast pointer pointing to the head of the linked list. Then we take a loop and we continue this loop till the first pointer is not equal to null. Alright, we continue this loop, and in every iteration of this loop we increase the slope pointer by 1, and we increase the fast pointer by 2 positions. Alright, so what we do, we writing the code here, slope pointer by 1 position and the fast pointer by 2 positions. Alright, and we continue this till first is not equal to null. Alright, so let's, in the other iteration, the fast pointer will also point to 2 steps forward, and the slope pointer will point 1 step. Similarly, again fast is not null, so first will also again go 2 steps, and slow will go 1 step. Next, again fast is not equal to null, so first will again go 2 steps. Here we have null, here we have null, and slow will go 1 step. See, when fast is equal to null, we have reached our destination. This is the middle of the linked list. Here is the middle of the linked list. Sorry. here is the middle of the linked list, and we have reached the middle. Now after we have reached the middle, what we can do? See, the twins are the first and the last are the twins. Similarly, second and second last are twins. Third and third last are twins, and the 0, 1, 2, 3, third and the fourth position are twins. So we are here in the middle. Can we get this position for each till we go forward? Suppose we are here, then we go here, then we go here. Can we get simultaneously these positions when you are here? Suppose you are here, we get this position. We are here, we get this position. We are here, we get this position. Can you think of a data structure how you can implement it? So you guys might be thinking that we can use a vector to implement this. Of course we can use a vector, but we have a ready-made data structure for just this kind of work. That is a stack. Alright, we make a stack here and we do that finding of the middle of the linked list and inserting into the stack simultaneously. Okay, so here is our slow pointer, here is our fast pointer, both pointing to the head, and we go on traversing this till fast reaches the null. Okay, and we put the data of the slow pointers into the stack. So at the first, slow is pointing here at the head of the linked list 1, so we put it into the stack. Now after putting the slow pointers data into the stack, we make the slow pointer traverse forward by 1 and the fast pointer traverse forward by 2. Now we check again, first is equal to null. No, first is not is equal to null. So we insert the data of the slow pointer into the stack. So we insert 9, we insert 9, and we move the slow pointer by one direction, by one position, sorry. Next, we also move the fast pointer by two positions. Again we check, fast is equal to null. No, fast is not equal to null. So we keep the data of the slow pointer into the stack 5, and we take the slow pointer and move it to the next step, and the fast pointer by 2 steps. Again we check, fast is equal to null. No, fast is not equal to null. Similarly, we put 7 here into the stack and we move slow by 1 and fast by 2 position. Now fast is equal to null. So what we do, we move out from the first loop, from the while loop that we did previously. We move out from there. And now what we do, we move the slow pointer in this direction. We move the slow pointer in this direction and add the values of the slow pointer to the stack, top of the stack elements, and then we pop it. So slow is here, we'll add 1 and the top of the stack is 7. So we'll add first 1 plus 7 is equal to 8. Then we pop the stack, we pop this element out of the stack, and we have the top of the stack as 5 and the slow pointer as 2. So 2 plus 5 is equal to 7. Next we again pop 5 out of the stack and move the slow pointer here. So now it will be 3 plus 9 is equal to 12. Again we pop 9 out of the stack, move the slow pointer to 7. Now it's 7 plus 1. So it's again 7 plus 1 is equal to 8. Now we make the top of the stack go out, pop it, and we move slow to null. When slow is null, we move out of the loop. Now we check which is the maximum, 8, 7 or 12. So 12 is the maximum. So 12 is our answer. So now let's go back to coding it. So we are here in our Leetcode and let's code our solution. So we have to return an integer. So let's take an integer as max is equal to 0 and then declare our stack of integer. Then we have to declare our slow and fast pointers. Slow is equal to head. Both slow and fast pointers will be pointing towards head. Now we do our finding the middle of the linked list loop. And what we did find the middle of the linked list, and also we used to put the elements into the stack simultaneously. So what was our condition? While fast not is equal to null. So while fast not is equal to run, what did we do? We put the data of the slow pointer into the stack. So how to put into a stack? We'll use just st.push slow.val, the value of the slow pointer, and then we'll increase slow by 1 position, and we have to increase fast by 2 position. So we have found out the middle of the linked list, and we also have our stack ready. Now we just have to make the sum of the slow pointers data and the top of the stack, and then we have to pop the stack. So our next loop will be, how long it will go? Till the slow pointer does not reach the end of the linked list, that is slow not is equal to null. So while slow not is equal to null, what you have to do? We have to update the max variable as max of the sum of the slow and sum of the slow pointer and the stack stop. So how to get the top of the stack? st.top, and also the present max variable. So in this way, at every iteration, we are calculating whether our new addition value is greater than the maximum value or not, and if it is, we are updating our max value. Then what you have to do? You have to pop the top of the stack so that we get the next element, the twin of the other, and we have to increase the slow pointer by 1 position, and then we'll just return our maximum. So yeah, this is the code. Let's run our code. Alright, giving right answer. Let's try some test cases like 1, 6, 3. Let's try this test case. Okay, so one more, because linked list will always have to be of even length. It's given in the constraint. Okay, so accept it. So let's submit it. Okay, yeah, accepted. But see, our solution is not the best. It's not the best because we are using some extra space. We are using some extra space in the stack. We're using some extra space. So as this video is getting longer, in the next video, I'll tell you how to optimize this solution without using any extra space. Till then, happy coding. I hope you liked the video. Leave a comment and please subscribe so that you get the notification for the next video. Thank you.